This is the lesson for Chapter 6, Section 1, titled Relations and Functions. And so, when we're looking at functions and relations, we're looking at inputs and outputs. And so we're going to talk about an ordered pair real quick. Ordered pairs we've seen quite often. We use those to graph points on a line. And we call the input is the x component. And another word for the input, again this is the x value in the ordered pair, is also, it's called the domain, and so sometimes you'll see that term instead of input. The output is the y value of the ordered pair, and you can see that right here. They're showing the y component of the ordered pair. They're calling those outputs. Another word for that is the range value, and so we'll see that term used sometimes. So relation is just a set of ordered pairs, and this is a way of conveying that set of ordered pairs. We could either show it in this form, and sometimes what they'll end up doing is use a brace, and they'll write down the ordered pairs inside that brace. And so this would be a relation, a way of showing that. And another way of showing that, that might take up a little bit less space, is also a mapping diagram, where the inputs are usually on the left-hand side, outputs on the right. Now we definitely know the outputs are 1, 2, and 4 because of the arrow right here. It goes from the 0 to the 1. And so what they're trying to convey is what the ordered pair is. So for the input 0, we get an output of 1, and that's what this ordered pair is, 0, 1. For an input of 1, we get an output of 2, 1, 2. And for an input of 2, output is 4. And so that's what we're going to be doing on these problems. It says to list the ordered pairs shown from the mapping diagram. So here, this input of 2 goes to the 3, so that means that that ordered pair would be 2, 3. Where the next one, we have an input of 4, and that goes to the 5, so that would be 4, 5. And then here we have an input of 6, well that goes up to 1, so it's 6, 1. And over here we have an input of 8, and that goes to the 7, so we have an output of 7, so 8, 7. And so that's all we're doing, is just listing the ordered pairs. On this next one, we have an input of 0, so 0, and it goes to 7. And here we have an input of 1 that goes to 8, so 1, 8. Here we have an input of 5 that goes to 1, so 5, 1. And the last one is 6, and it goes to 7, so 6, 7. So that's understanding what a mapping diagram is and changing it to an ordered pair so that you can go ahead and graph those points. And that's what we're going to be taking a look at next, is a graph. And so these are just a series of ordered pairs, and we want to write them in a mapping diagram. So this ordered pair right here is 1, 8. This ordered pair is 3, 6. And this ordered pair is 5, 4. And so what we're going to do is put them in that mapping diagram, which will list the input, and then we'll have an output. And I'll start by listing my inputs. My inputs were 1, 3, and 5. My outputs were 8, 6, and 4. And so I'm just listing what they were. Here are the inputs, 1, 3, 5, 8, 6, 4. And so if I want to do a mapping diagram, the input of 1 has an output of 8. The input of 3 has an output of 6. Input of 5 has an output of 4. And then I want to describe the pattern of inputs to outputs. And so the pattern would be this. My inputs are increasing by 1, or by 2 actually. Increasing by 2, 1 to 3 to 5. Increasing by 2 as the outputs are decreasing by 2. And so that's what's happening there. And one other thing I want to take a look at is a function. And so a function is a certain type of relation. So we're going to call a function is a type of relation in which each input has only one, and that's the critical part. Each input has only one output. And so let me give you an example. And so this is a function, and it's a function because you see 1 only has 8 as an output. 3, the input 3, only has 6 as an output. 5 only has 4 as an output. So this is a function. This is a function, and my reasoning again would be each input 1, 3, and 5 have only one output. And so let's take a look at an example that would not be a function. An example that would not would be like this. And one thing I don't have to do is write the input and output as headings there. I'll know what the input is if I just look to see where the arrow goes to. So let's say I had 1, 2, and 3. And then I have numbers of 5 and 6. And so let's say I have this. These are my inputs. My input of 1 has an output of 5, input of 2 has an output of 6, input of 3 has an output of 6. So this is a function. So a function, because each input, and I'll list those inputs again, 1, 2, and 3 have only one output. And so again, the input of 1 only has 5, input of 2 only has 6, 3 also only has 6. But this would be one that is not a function. So let's use those same inputs, 1, 2, 3. Let's say I have 5 and 6 again, and I'll go ahead and draw the same sort of image that I had before, 1 to 5, 2 to 6, 3 to 6. But let's say I also do 1 to 6. So this is not a function, and here's the reason. It's because if you look at the input of 1, the input, not a function, the input 1 has two outputs. And that makes it not a function, because when I go ahead and plug a number in for 1, I get an output of 5, but I also get an output of 6. And so it's not a function. A good representation of a function that you've seen before is a soda machine. And so if we look at a soda machine, like let's say it's Coke here, and we've got these different buttons. And let's say we go ahead and select one of the buttons right here. I select this button, and a soda pops out. I would expect the same soda to pop out each time. So if I press this button, I would expect, let's say, a Coke to pop out. But if, let's say, I press the button and a Sprite pops out, that would not be right. That would not be, the function would not be correct, because I would expect the same thing to pop out each time. And that's what's happening here. We're pressing the number 1 button. I'm pressing number 1 right here, but sometimes I get a 5, and sometimes I get a 6, and so that's not a function. I should get the same exact soda every time I press that button, because that's what the function says, or that's what the machine says I should end up getting. So that is a representation of a function. Let's take a look at the last problem here. It says the table shows the number of beads needed to make a bracelet, and so here are the number of beads. Here are the here are the lengths of the bracelet, and here are the number of beads needed. So we're supposed to draw a mapping diagram. So I'm going to have an input and an output. And I'm going to start with my inputs. My inputs are 6 inches, then I'll need 12 beads. My input is 7 inches, then I'll need 14 beads. My input is 8 inches, then I would need 16 beads. And an input of 9 inches leaves me with 18 beads needed. And so what's the pattern? Well, the pattern is this. I've got, as my bead, or this, the length of the bracelet increases by 1, as the length of the bracelet increases by 1 inch the number of beads increases by 2. And so this is a function because each input has one output. And that's what we'd expect. It makes sense, because if I have it as 6 inches, we're only going to have 12 beads. We're not going to have 11 beads. If I had an input of 6 inches and I had 2 different outputs, then it would not be a function. So those are the types of problems that you're going to end up seeing on tonight's homework. Goodbye.